Let us have more examples of decoding a message. So we are asked to use the inverse of this matrix to decode this cryptogram. Pause the video and let's see if you'll be able to decode the message. Alright, so we have a 2 by 2 matrix, and finding the inverse of this matrix is easier. Rather, we're going to use our formula. That would be 1 times 5 minus 2 times 3 here, multiplied to 5, negative 2, 3, and 1. So here you go. And this will actually result to us having the inverse of the matrix negative 5, 2, 3, and negative 1. So this is what we will now multiply to our cryptogram. Since this is a 2 by 2, we shall group our cryptogram into 1 by 2 matrices. And it's exact, so we don't have to place any zeros here. So showing our first decoding, we're going to have to multiply 1121 to our inverse, and this will be giving us 8 and 1. Let's go down. There you go. For our second one, multiplying 64 and 112 to our negative 5, 2, 3, negative 1 here, we are going to come out with the matrix 16, 16. Then we're going to follow through with all the other 1 by 2 rows. Alright, we have our now coded and decoded rather, our decoded matrices here. So now we can write that down. Now we're going to have 8, 1, 16, 16, 25, 0, 14, 5, 23, 0, 25, 5, 1, and 18. So let's take a look at that. 8 is H, 1 is A, so this is also A. 16 is P, so this will be P. 25 is Y, this is Y also. All zeros are spaces. 14 is N, 5 is E, this is also E. 23 is W, and 18 is R. So the message is actually Happy New Year. There you go. Let us have one last example. Use the inverse of this given matrix A to decode the given cryptogram. Pause the video and try to see if you'll be able to decode this message. Alright, so first we need to find the inverse of A, and to do that we would need to be performing our Gauss-Jordan elimination. So we write it like this: 0, 1, 0, 4, negative 5, 3, 0, 0, 1. Then we perform our Gauss-Jordan elimination. So leaving that to our viewers, we're going to have our first row as 1, 0, 0, 11, 11, 2, negative 8, 0, 1, 0, 4, 1, negative 3, then 0, 0, 1. This becomes negative 8, negative 1, 6. So this is telling us that the inverse of A is given by the matrix 11, 2, negative 8, 4, 1, negative 3, negative 8, negative 1, 6. Since we have a 3 by 3 matrix, we need to group this cryptogram into 3. So that's 1, 2, 3, 1, 2, 3, another 3 here, another 3, another 3, another 3, and that's 42, negative 48, 32. No zeros, so we're good. So let's just go up that a bit. Let's decode the first one. 112, negative 140, 83, multiply it to our inverse here, -8, -1, 6, and we're going to have the numbers 8, 1, and 22. Let's also show the second one, which is actually 19, -25, 13, multiplying it to our inverse here. There you go. We are going to have the numbers 5, 0, 1. Let's now show for the other row matrices. And there we go. We have our decoded numbers already. So let's place them here. You can place them here. So we'll have first 8, 1, 22, 5, 0, 1, 0, 7, 18, 5, 1, 20, 0, 23, 5, 5, 11, 5, 14, and 0 at the end. So all the zeros are spaces, just like that. We have 8 as H. All the ones are A, so this is A. Alright, 22 is V. 5 is E, so this is also E, and this is also E. Then 7 is G. 18 is R. 20 is T. Another 0, space. 23 is W. Another E here. 11 is K. This is N. Oops, we forgot the 4 there. There you go. This should be 4, which is D. Then this is 0, which is a space. So, our actual message is have a great weekend. And that's how we decode matrices using the inverse of a matrix and matrix multiplication.